Okay, we're back with the 2019 AP Calculus AB multiple choice. We left off in number 23. So let's go ahead and continue this. Dice, the base of a solid is the region in the first quadrant is bounded by the x and the y-axis, the graph of e to the x, and the vertical line x equals 1. The cross-section perpendicular to the x-axis is a square. What's the volume? So in order for us to do the volume, we're going to do the integral from a to b of the area of the cross section. And in this case, the cross section happens to be a square. The formula for the square is side squared. Now, doing a graph for this scenario can help you visualize the setup. E to the x is an exponential function that looks like this. And it is bounded in the first quadrant with the vertical line x equals 1. So we're talking about this region right here. And that means my limits of integration are going to go from 0 to 1. Now, the vertical distance between the function and the x-axis, that's going to be one of the lengths, the length of the side of one of the squares. So the volume is the integral from 0 to 1. And that length is going to be given by e of x dx. So we can go ahead and simplify this to e to the power of 2x dx. And now we go ahead and find our antiderivative. The antiderivative is e to the 2x, but we're going to multiply by the reciprocal of the derivative. Plug in your values. 1/2 e to the 2 minus 1/2 e to the 0. And that gives us 1/2 e squared minus 1/2 times 1, but that is our answer, B. Okay. 24. The graph of the piecewise linear function is shown above. What is the value of the antiderivative of the integral from 0 to 12? Well, the antiderivative of f prime of x is just f of x. And we're going to evaluate that from 0 to 12. We go ahead and plug in our numbers. Now, to get f of 12 and f of 0, we're going to use the graph. F of 12 looks like it's -4, while f of 0 is +4. So we have -4 minus 4 equals -8. Okay. 25. The equation is a particular solution to which of the following differential equations? Okay. This question is a guess and check method type of question. We are going to have to find the derivative, though. The derivative here is 2e to the 6x times 6, which simplifies to 12e to the 6x. The second derivative is 12e to the 6x times 6. Whoa. And this derivative simplifies to 72e to the 6x. So now it's just a matter of picking one of the equations and making sure that it does equal to 0. You know what? I'm going to go ahead and check B. Somehow B is calling my name, so let's see. 2 times the derivative minus 12 times y, which is 2e to the 6x minus 5, should equal 0. This is 24e to the 6x. Oh, I forgot a plus 5. Plus 5. Oh, and it's not going to work out. Watch. Minus 24e to the 6x plus 60 plus 5. These cancel. But 60 plus 5 is not 0. Okay, so it's not B. Let's just try A. Just because I don't want to deal with such a long equation right now, but if we have to, we're going to have to. Okay, the derivative minus 6 times y minus 30 is equal to 0. Okay, let's hope this one works out. 12 e to the 6x minus 12 e to the 6x plus 30 minus 30 is equal to 0. And this actually works out because that's 0. This is 0. And it does equal 0. All right. What is the value of x at which the minimum value occurs on the closed interval from 0 to 1? What's the x value of the minimum? If I want to find my minimum, I have to find my derivative. So 3 times 4/3 x to the power of 1/3 minus 2. We simplify it. We set it equal to 0. Okay, we solve for x. Divide by 4. Cube it. 1/2 to the power of 3 is 1/8. That's my critical point. Now, next, normally I would go and do my number line. But in this case, I'm going to go ahead and skip it because of the way the question is phrased. It says, at which x value do we have a minimum? And there's only 4 choices, and I already got my choice, right? It's 1/8. If there was another choice that said none and 8, then I would have to do my number line and check. But I can tell you for a fact that when you do your number line, the first derivative is going to be negative, and then it's going to be positive, giving us a minimum. 27. At t is equal to 0, a storage tank is empty. It begins filling with water. The depth of the water is increasing at a rate of Wt. Which of the following is the best interpretation of the statement W prime of 2 is greater than 3? Before I start looking at my answer choices, we got to keep in mind that W of t is already a rate. And more importantly, it's going to be feet per hour. So when you take the derivative of that, you're going to get a second rate, which is feet per hour squared. Just knowing that fact, we can probably cancel out some of these choices. 2 hours after the tank begins filling with water, the depth of the water is increasing at a rate greater than 3 feet per hour. Look at the units. That's wrong. Over the first 2 hours, no, it's not over the first. It's not on an interval. It's at the second hour. It's an instantaneous rate of change. Plus, look at the units. 2 hours after the tank begins filling with water, the rate at which the depth of the water is rising is increasing at a rate greater than 3 feet per hour per hour. That looks like the winner to me because we have per hour per hour. Over the first 2 hours, no, that is an interval, right? That's saying from 0 to 2. And that is not what a rate is. A rate is instantaneous. Okay. 28. A person stands 30 feet from the point P, watches the balloon rise vertically. The balloon is rising at a constant rate of 2 feet per second. What is the rate of change in radians of the angle at the instant when the balloon is 40 feet above the point? Okay. So we're going to go ahead and call this height. And they're saying that the rate of change of the height is 2 feet per second. What's the rate of change of the angle? D theta dt is the question mark at the instant when the balloon is 40. So that means the balloon has a height of 40 feet. Okay, so the first thing we got to do here is we have to find an equation that relates everything here together. And for that, we're going to be doing tangent of theta equals h over 30, because tangent is the opposite over the adjacent. And because we have to find d theta dt, I'm going to go ahead and isolate it by doing tangent inverse. Okay. And then from here, we're going to go ahead and take our derivative, d theta dt. The derivative of tangent inverse is 1 over 1 plus u squared times u prime. Okay. D theta dt equals 1 over 1 plus h over 30 squared times the derivative of h over 30. Think of it as 1 over 30 times h. So its derivative would be this. Okay. Now go ahead and plug in the values that we were given. D theta dt is 1 over 1 plus... Okay, we were told that the height is 40, and 40 divided by 30 is 4/3. Times 1 over 30 times h prime. H prime was 2. So d theta dt equals 1 over 1 plus 16 over 9 times 1 over 15. D theta dt. Okay, we're going to have to get a common denominator. This 1, you can think of it as 9 over 9. Times 1 over 15. D theta dt equals 1 over 25 over 9 times 1 over 15. D theta dt. To fix this fraction, we're going to take the 1 and we're going to multiply by the reciprocal. So that's going to give us 9 over 25. Okay. The 9 and the 15, they can be reduced by 3. So that's going to be 3 over 25 times 1 over 5, which gives us 3 over 125. Ooh, let's see if this is here. Oh, yes, it is. Man, what a problem. This one was tough. Okay. What's going on with my computer? Okay. 29. How many vertical asymptotes does the graph have? Well, for this one, we're just going to have to factor it out. So y equals x minus 2 divided by x squared minus 4 times x squared plus 4. We factor it out using difference of squares. And then we can take it one step further. We can factor out the x squared minus 4 by using difference of squares again. Oh, I forgot my minus 2. And right here, you can see that these cancel out. And then from here, we're just going to go ahead and make the denominator equal to 0. Make the denominator equal to 0. And you don't even have to solve it. You can already see that the answer is going to be 1 vertical asymptote, because this one is going to give us a non-real solution. So we have 1 vertical asymptote. If you guys didn't simplify the function, maybe you would have made the mistake of getting 2 vertical asymptotes. But the factor that cancels out, that's a whole, aka a removable discontinuity. So I know the question wasn't asking this, but I'm just going to show you. X equals 2 is my removal of discontinuity, a whole. Okay, the last one. For what value of b does the integral from 1 to b x squared dx equal this limit? This is one of those lessons that we skipped because I classified it as a BC lesson. So this is going to be one of the questions where I think I'm just going to have to show you in class. That way everybody hears it at the same time. Okay. Just like in the last practices that we did, there's not a lot of questions that come up like this. So that's kind of why I labeled it a BC topic. Because at most, we're going to get one question with it. So I'll skip it for now. I'll save it for class. And I'll see you then.